An object projected upward with an initial velocity of 48 feet per second will rise and fall according to the equation s of t equals 48t minus 16t squared, where s is the distance above the ground at time t. What will be the object's maximum height? So first, if you look at that equation, it's another quadratic function. Apparently, the trajectory of that object follows a quadratic function, a parabola. So that's basically what the movement is going to be about. And because the coefficient of t squared is negative, so we know that the parabola opens down, just like the previous problem. So we could actually do like a sketch of what the graph's going to look like. So first, let's do the axes. The two axes that we have right here are not x and y. The trajectory is based on time, which is t. So we have t as our horizontal axis, and then s represents the height of the object at time t. So the vertical axis is s. And then we could kind of do the sketch, right? It's going to be a parabola that looks like this. Something looks like this. And then, of course, you have a maximum point right here. And as you can see, this is the vertex of the parabola. And at this point, or at this time, the object will reach its maximum height. So you basically are looking for the y coordinate of the vertex. That's basically what this question is talking about. Let's first write down the function again. S of t equals, I'm going to switch the two terms a little bit. Instead of writing 48t first, let's do negative 16t squared first, and then plus 48t. So this is basically the function. And we're going to look for the vertex using what we just reviewed in the previous problem. So first is the general equation, ax squared plus bx plus c. So in this case, it will be, the general will be at squared plus bt plus c. So that would be the general equation. And apparently we do not have a c, so apparently c is going to be 0. According to this general form, our a is negative 16 and our b is 48. So write those down first. And then since we're looking for the vertex, we're going to use the formula. The x coordinate of the vertex, it's the same formula, negative b over 2a. And you plugged in, so it'll be negative 48 over 2 times negative 16. So that's negative 48 over negative 32. And of course, you could simplify this. If you simplify this, they do have a common factor of 16, or rather negative 16. I'm going to first make both of them positive and divide both of them by 16. So this will be 3, this will be 2. If you simplify, it's simply 3 over 2. Or you could use your calculator, it's just 1.5. And then we're going to find out the y coordinate of your vertex, y sub v. In this case, it's simply s of, you just plug in the x coordinate that we just plugged in. The x coordinate we just calculated, which is 3 over 2. So it's s of 3 over 2. And that will be, so it will be negative 16, 3 over 2 squared, right, plus 48 times 3 over 2. So I'm just using this equation right here, plugging t equals 3 over 2. So actually, let's change these x and y. So I want to use the variables that are in this case. So you have a t, and then you have s. Those are the variables that they use. But it's essentially the same thing as xv and yv. All right, let's calculate what this is. So we have negative 16 times 9 over 4 plus, over here, you could divide 2 into 48, and then it's going to give you 24 right here. 24 times 3, that's 72. And then the first product, 4 goes into 16 4 times. And that is negative 4 times 9, which is negative 36, plus 72, that is positive 36. So apparently the object's maximum height is 36 feet. So you just write the object's maximum height is 36 feet. And then you could box that.